Hello, today I showed you the first chapter about the basics computer knowledge and computer evolution. Here there are the topics today. The first I showed you about the mechanical computers and the moving to the vacuum tube, and then I showed you the silicon transistors. After you know the evolution from the mechanical to the semiconductor in computers, I show you the difference from four things, as is a microprocessors, microcontroller, DSP chip, and GPU. Now we are talk about the mechanical computers. The first mechanical computer occurred in 5,000 years ago by the researcher found abacus. Here in this picture it is an abacus. They found in the China, Europe, and Russia. The abacus have a lower decks represent in one for each breed, and the upper decks represent 5 in each breed. In this is the abacus. Abacus have abacus from Chinese style, abacus in Japanese style. It is the same thing but different in the techniques for calculation. Here in this, the first activity, we will play the abacus. That is a simulation from the internet. We are in these links. By here, I set the calculation addition 83 at 12 on the simulation. Click in this link. In this simulation, I set the values 12. 12 here, 1, 2, it is 12. 12 plus 83, 5, 8, 3. This is a 95. The abacus not only calculate in the addition or subtraction, you can calculate in multiplication and division. By in this example, you can search this from the internet from the links below. The abacus are in a group of the mechanical calculators. The next step when the human move through the Iron Age. The Iron Age, after the humans make a gear. This make gear ratio. If I have a big gear, a small gear connects to the big gear, small gear. The small gear rotates 10 rounds. The big gear move only 1 round. Here this is a ratio 1 to 10. And in this, and after the Pascal in 1642, they developed the mechanical computers. Here in this is represent the first digits, 10 digits, 100, thousands, 10,000s, and 100,000s. By inside here, this is a gear ratio. For the mechanical calculator developed until to the last mechanical calculator used in the bank. Here in this example, the mechanical calculator used in the banks. I show you the links from the internet by clicking these links below. Here, the mechanical calculator here have a rotation arm on the. Yeah, this is a rotation arm. When move the rotation by the cogswells to the additions and to the another side in the counter cogswells, that is a subtraction. You can set the value by move this arm to set the value. After rotation in this arm, you calculate the result shown here. In this example,
subtraction and division.
Subtraction and addition.
So if you notice every time, current counter is up by 1. So I'll keep doing that and just keep going up. But is 0, the output is going to be 0 because 0 plus 0 is 0. So set that.
Here, this is example for mechanical calculators. In these pictures, I show you inside the mechanical calculators. This is have a text in the arm, and have the gear ratio and represent in the value in each side in the gear. Okay, we move back to the slides. Then after the human found the electrical effects from the writing, and they found the electricals that is supplied from the fruit from some effect generated from the generator or motor. And then they create a new electrical device that is a light bulb. Yeah, in this is light bulb that is made in this picture here. It is a light bulb. Inside the light bulb have a small tungsten coil that is sometimes called a tungsten filament. When we supply the power to the tungsten filament, it's burned and generates brightness, because inside the light bulb it is have no oxygen, so not burned. Okay, here in this symbol, this is a represent a light bulb and have a tungsten coil. During you supply the power to burn this tungsten coil, generate a brightness, and the brightness this is the generates the free electron move it out from the tungsten coil. But the researcher, they didn't know the electron move it out, but in the research they put some plate here in another side and connect the plate to the batteries, and then after supply and burn the tungsten coil, they found some currents move it out from the batteries, move across the plate to the tungsten coil, and have the loop in this. This is have a current supply move it out from the battery. That is the effect from the, like as the induce the power or the induce the currents inside this circuit. But when the researcher reverse the battery pole from this is a positive pole and negative pole, and reverse in this is negative and positive, not induce, not have the currents move in the circuit. That is the effects from the in this device. That is have only one way current. That's called, after that is called the direct current or DC direct currents. And then after invent this device, we have the new device to change from the AC voltage, alternate voltage have this another side, positive and negative sides in sine wave, like as sine wave, to change it to the DC voltage. I will show you the voltage have two types. The supply from the generator. This is a AC volt, like in this picture here. AC volt have a positive and negative part, like as a sine wave. Then the voltage after pass the vacuum tube, that's called the diode, like as a diode. The voltage is allow pass only the positive part or negative path. If pass only a positive path, it will have only in this part move out from the voltage out from the vacuum tubes. To show you, it is a concept like as here. This is have only one part move out from the vacuum tubes. I can search the vacuum tube circuits from the internet, but I can show you the circuit in the electronics. In this is a diode, like as do the function like as the diode in the vacuum tube. When I supply the AC to input, the AC pass to the transformers. After pass the transformer is convert from the sine waves to the only one path in the positive path, that is a DC direct current voltage. Represent the diode as represent this light as the vacuum tube from this. The next picture I show you inside the vacuum tube. The vacuum tube inside the cut picture in the vacuum tube in the simulation in 3D is have the heater that is a tungsten coil and have the plate, have a plate. The plate called the anode, the plate outside called the anode here, and the plate inside close to the tungsten coil called the cathode. Like as the diodes. I will show you the next slide. The diodes have two pins here, anode and cathode. That is a name from the vacuum tube. When here I supply the power here on the left hand side to generate heat in the vacuum tube, and the right hand side this is supply pass to the vacuum tube that have function in diode. And here in these pictures, some developers they try to bring the vacuum tube to build a digital circuit. In this digital circuits have a function like as the exclusive OR. The exclusive OR input two inputs A and B and Q for the output. The A have the four combinations 0, 0, 0, 1, 1, 0, and 1, 1. Only the input 0, 1 is generating output 1, 1, 0 is generating output 1. For it is an example for the like as a project in the class for build the vacuum tube to make a digital circuit. But for this is the idea to show you when the developer they made the computers from the vacuum tube. I will search from the first computers that is made from the vacuum tube to show you. The ENIAC is the first computer is made from the vacuum tube in 1942. In this, I searched from Internet computerhistory.org. This is a ENIAC. Look at this. This is a small circle. It represents the vacuum tube. The ENIAC have 18,000 tubes in the room. In the room have warm or hot, and use more power for supply in the calculation. Yeah, you can get more idea or the by list is from in this website. The next device for passing a few decades that is the cathode ray tubes, like as a television. This is a television. The television screen is made from glass. Inside that is a big vacuum tube. By the structure, the vacuum tube, the big cathode ray tube that is have a tungsten coil. Here it tells when supply the power to tungsten coil, it generates heat, and exactly it generates the free electron move without spin around this. And then the electron have make a beam electron by the effect from the high voltage. Allow a 2000 volt allow here to beam the electrons like at the line, electron line, and the electron line move from the tungsten coil move to hit on the skin. In the skin surface, this is a cover with a phosphorus. When the electron hit to the phosphorus, it generates a brightness, and then how it is have a dot of the electron on the screen. The techniques for move the electron scanning on the screen that have the coil. Is a copper coil in the x-axis, on the y-axis expressed and y plate, and then supply the voltage to coil x and y. The coil generates the magnetic effect to the electron. Electron move from the x and y axis, scanning from the first left to the right below. By scanning very fast, generate the brightness, and inside here have the mechanisms to turn on and turn off electron during scanning that will generate the pictures by technique of the scanning. Exactly when the television that have the color television, it have a 3 electron gun to generate RGB red, green, blue. That is the last device that's very big for representing in the vacuum tube technology. I searched from the internet and found some researcher. During the researching, that is a vacuum tube in NASA runs in 460 gigahertz. This is a very fast, faster than the transistor. The last technology in transistor, I think, is run in the 10 gigahertz enough. This is running in very high frequencies, 460 gigahertz. But in this technology, they try to bring the concept of the vacuum tube to build in the transistor that's called vacuum channel transistor. For more detail, you can search from the internet and read it. Here in this is activity to 1.2. In this activity, I show a circuit represented in the fluorescent lamp. In your home, I think your home have a lamp like as the long tube that's called in Thai called the Lord Neon. That is a fluorescent lamp. Inside the fluorescent lamp have two tungsten coil here. It have a ballast and a starter. During starting the fluorescent lamp, it generates the heat in the tungsten coil at the corners on the left and right. During generate heat, it generates the free electron, and electron move from here to here. During electron movings, it passed to the cover, the tube that is covered with the phosphorus. The phosphorus is generate the brightness. So this is an effect from the fluorescence lamp generate the brightness. For the current technology is different. We use the same structure, the lamp, but inside the circuit is different. The size, the structure inside is different. The tube, like as the fluorescent inside is made from the LED. LED is a LED connected together, connected in the line, and generate the brightness from the LED, not like the technique as the fluorescent lamp and vacuum tube. And here in this picture, if you bring the fluorescent lamp close to the high voltage pole, electrical high voltage pole, here in this is an electrical high voltage pole have the very high voltage, about the I think it's 1020 kilovolts. 120 kilovolts. 120 kilovolts. And in the 120 kilovolts have more magnetic fields, and exactly magnetic field and electron is spent out allowed here to hit in the fluorescence lamp and generate the brightness without power supply. Okay, now we will move to the third era or third technology. In this is a current technology that is a human use in the current technology, that is a silicon. Here in this picture, I show you the periodic tables. Where is the silicon? Where is the silicon? Can you find? Here this is Si is silicon, Ge is germanium, As is arsenic, and B is boron. In the periodic table have the value on the top here. This is a 14. 14 represents the number of the electron in the inside of the atom have the 14 electrons. So in the silicon, that's called the semiconductor. Semiconductor is mean not conduct or not resistant. It is between conducting and resisting. The silicon is made from sand. Sand you can create the silicon from sand or crystal or rock, in some kind of the rock you can make it silicon. The technique change the sand to the silicon, that is bring the sand from the seaside, burn the sand with the temperature over 5,000 Celsius, and then after sand burned, they spending the sand and change the sand to and loading the sand, that is the sand is like as a liquid until it's setting to the solid. That is a change from seasand to the silicon, that's called pure silicon. After they have the pure silicon, they use the cutter to cut the silicon into the small piece, like as a disc. That's called wafer. Yes. wafers. And then wafer is changing from the pure silicon to impure silicon by exposures. The light, high intensity lights generate from the X-ray, and the lights have the film or a circuit on the top exploding to the wafer. The environment exposures the light. That is the cause environment have a toxic gas, a lot of toxic gas, and then after exposure, this is a change status from the pure silicon to impure silicon. Here it's like have a lot of block inside here. In each block inside the wafer represent the chip, and then the chip maker cut in each block and put it to the package to make microchips. Now the technique that we choose to focus, that is how changing from the pure silicon to impure silicon. Now changing from the pure silicon to impure silicon. When changing to the impure silicon, that the chip maker have two types of silicon, that's called p-type and n-type. Okay, now I show you how to change from the pure silicon to impure silicon by the concepts. If I have a pure silicon from the process that I mentioned last slide, and here this is an atom of the silicons have 14 electrons. By the covalence electron, the cursor, the circle outside have 1, 2, 3, 4, and you count all here is have 14. They change from this pure silicon to impure silicon by mixing the atom from the B is boron. The borons have, when you look at the periodic tables, the borons have number 5. That means have 5 electrons here, 1, 2, 3, 4, 5. When mixing, this is a focus at the outside, that is a called covalent electron. Here is have 4, 1, 2, 3, 4, and here have only 3, 1, 2, 3. When mixed by fill a little bit boron, and the impure silicon, some atoms have only 3 electrons in the covalent electrons, and have not electron here. That's called hole in this. That means this is not have all electron in here. So this is called p-type for impure. This is p-type in the impure silicon. Now for change from the pure silicon to n-type. In this is a p-type, and now we will talk about the n-type. The n-type, this is a mixing with Sb. This is Sb is antimony. Antimony have I think it is a 51. Antimony has 51, yeah, 51 electrons, and electron at the covalence have 5, 1, 2, 3, 4, 5. When mixing the silicon and antimonies, mixing a few antimony, it changes from the pure silicon to impure silicon to be the n-type silicon. Look at in these features. Look at in covalent electron. it have 1, 2, 3, 4, 5. That is have not only 5, not have 4 electrons, it have 5 electrons. So here in purely silicon, that is changed name to n-type. Okay, we can conclude that the pure silicon convert to impure silicon, we have two types, n-type and p-type. For the n-type, for the p-type have hole, and n-type have more electrons. Okay, when they bring the p-type and n-type connected, this is a atom of electron, n-type and p-type connected in the chip, connected to the chip. When I bring n-type and p-type join, at the position of joint between n and p is electron and hole move to the make a layer that's called depletion layers. By moving like as the effect when you bring the magnetic have n and s. When you bring the same the different size in the magnetic courses together is have the jointed, and in the same time is have not jointed. So this is a light as the effects here. The hole is a positive, the electron have a negative. During the joint position, that's called depletion layer. The depletion layer have a small electric field, cannot supply to the motor. That is a field during the joint position. This is a small voltage that called electric field. When I connect n-type and p-type from the battery to load, when I supply to right direction, the same direction, the depletion layer will decrease the size, and electron can move from the left to right. And when I supply to the different side of the power supply, maybe the depletion layer is growth and block the voltage or current path to the circuit. Okay, this is an effect like as a conducting and resistance. So when you supply the power supply, the voltage from the power supply right the direction, that is the change status to conducting. And then when you supply the not right direction in the reverse direction, it's not supply, not induced, not in change from the conducting to resistance. So that's called the semiconductor. From the p-type and n-type joined, that's made to the new device that's called diode. Here in this picture is a diode. Like as you test in it's like the function like as the LED is made from the diode. Example here in this activity, I connect the diode to the in circuits have a battery, diode and lamp. When I connect the positive pole to the in this is called anode. In this side called anode, and here in this side called cathode. And connect positive to anode, and cathode connect to the lamp to the port negative. This is generate the brightness conducting. But when I reverse the supply voltage from the negative to the anode, that is not connected, not conducting. Okay, Now I show you the next device in the electronics. From the last slide, I talked about the diode. Diode have two pins, N and P and N. This is anode and cathode. But in the diode have a function to block the voltage when you supply wrong direction. Has only one direction. That's when you convert AC volt, you can convert from AC volt to DC volt with a diode. And in the new device, that is the silicon transistor. Before I tell you about the silicon transistors. Can you remember the vacuum tube? For the vacuum tube, this is have a plate here and tungsten coil here. In the research, after the researcher found the diode that do function like as the diode, they put some grit, it not solid plate. It have a hole grit. Put it between a plate and tungsten coil. Example, I put small grit like as net. Small grit to here, small grit here. I will draw a small grit. This small grid. This small grid connect to another power supply. Why they put the grid? Because they try to check the size of the electron. But the electron is very small. I think 1 minus E19 for the electron voltage. I don't know the electron size exactly, but it's very small. When they supply the voltage power to the grid and another power, they can control number of the electron moves out from the tungsten coil to hit the plate. When supply the voltage right direction and more voltage enough, it can bring the more electron move from tungsten coil to hit the plate. But when supply the voltage to wrong direction, can block or send or block or give a few electron move from the tungsten coil to hit the plate. Like as you control the water valve or water tap. When you turn on 100%, the water is fall out more water out from the water tap. And when you move the water valve to 50%, this is you have a few water move out from the water tap, like as the same concepts. Okay, now we move to the transistors. The transistor do the function like as the vacuum tube that I told you. For the vacuum tube, when put the grid, that's called the diode. The silicon transistor have 3 pins: source, gate, and drain. Source, gate, and drain is do the function like as the FET. In this title called transistor, the transistor, if you search from the internet, the transistor have base, collectors, and emitters. And you can do the function control the voltage or power, use the transistor or FET. For in this picture I bring from the internet is the FET. The FET have 3 pins: source, gate, and drain. Why I bring source, gate, and drain from the FET? Because the name source is a supply the power. Gate do the function like as block the electron, and drain, this is the electron move from the source to drain. The electron move from source to drain in these features, move to source and pass gate and move out from drain. By gate have another power supply. When you supply the voltage right direction, it is make the electron move with more electron from source to drain. When you supply wrong direction to gate, will block the electron moving from source to drain. Like as you control number of the electron from source to drain via gate. So the function of the silicon transistor or FET is will create a new device that is the power amplifiers or transmitters or generate more power. Like as you bring a few power to control more power. Like as you bring a few power supply to control a big motor, turn on or turn off, or running in low speed or high speed. Here in this is I supply more power, supply the negative to the gate, block the electron move from source to drain. Now we look at the next slide here. Not only transistor in the electronics world, we have FET, MOSFET, IGBT, and more device in the electronics world. But for the more detail, I not told you the function of FET, MOSFET, and how to test the MOSFET and MOSFET. It is a scope move to the electronic circuit. But in this class, we cover about the overview, the electronics, and also bring you know about the digital circuit. If you need to know more detail about the FET, MOSFET, you can read or look the detail from the internet for the FET and MOSFET. Not difficult for you for learning. Okay, here this is FET have the T-pin, drain, source, and gate. Drain, source, and gate. Here in this picture, they bring the MOSFET to control a few voltage, 5 volt, to control more power here in source and drain side. For the transistors, the chip maker will bring the transistor to make a big circuit. Now from the past one, I told you about the transistor technology, and moving back to the slide. Here I told you the transistor, FET, MOSFET. Now the chip maker, they can make the device is two methods. That is the discrete circuit and indicated circuit. For the discrete circuit, this is install the transistor in the PCB. In the features, here this is a circuit of the IC 555. What is the 555? The 555 circuit is a circuit to generate the clock. You can make the clocks to control the motors. By use the clock speed to control the motor running speed, and you can reduce the effects about the debrowse from the keyboards, and also do anything about the clocks. Inside the IC, inside the circuit 555 have a lot of transistors here. In this symbol, in this is circuit of a 555 have here. This is a transistor 1, 2, 3, 4. I think it's over 20 transistors in this circuit. Now for the chip maker, when you have individual transistor or discrete transistor, you can build by install it into the PCB like as in this PCB board. The circuit is very large. You can hold the circuit into your two hands. Now for the second method, if the chip maker they build the circuit by create it into the wafer and then cut the wafer and install it into the packet. Here this is a circuit inside the IC. Inside the packet we call integrated circuit evaluation from IC. Here the IC can reduce the circuit size from 2 hands only on your fingers. Now we talk about the size of the transistors. In this slide have two parts on the table in the left hand side. In the blue table, that is related of the number of the transistor in the circuit and into the integrated circuit. And the right hand side, here is a red table that is related about the transistor size. When I comparison, if I install the transistor into the IC, about 10 transistor into an IC, we call the technology is a small scale integrated circuit. Yeah. And today for the new transistor, for the new microprocessor and microcontrollers, today if you buy a Core i7, inside the Core i7 have the transistor over 1 million transistor in the packet. And the left and the right hand side, in each transistor, that is have a difference the chip, the structure inside. The size of the transistor relate to the current transference is related to the voltage. For the transistor to control in the motors and the high power circuit that have arranged the scale in the chip inside, so that is packaged into the package like as this. This is a connect to the heat sinks to distribute the transfer the heat from the transistor. That is in this picture, I mean the transistor inside the microprocessors. When the chip maker create the transistor and the size of the transistor to very small, it is related to the low power. And for today, I think for today the chip maker I found from the news that the chip maker announcement they can create a small size transistor about 3 nanometers. Okay, for the 3 nanometers, what is the 3 nanometers? The 3 nanometer relate to example you have a distance from here to here about 1 meters. That is 3 nanometer. You cut in this about 3 billion piece. That is a very small object into the microchip. So the transistor today, I think the chip maker have a limit at about when they create a chip that is less than 1 nanometer. That is very hard for control for making the circuit. For the next slide, we will talk about the overview the electronics device, and I show you to know the electronic device. The electronics device that have two types. The first that is passive device, and second that is active device. In the passive device have about 4 devices in the group. The first that is capacitors. Capacitor. In the Thai language we call C. This is a capacitor. The capacitor have many types inside the capacitor. By here, in this picture, this is we call electrolyte capacitor. The electrolyte capacitor have polarities and positive and negative polarities. And in this side is negative polarity, and here this is positive polarity. When you install the capacitor to the motherboard, to the circuit, please make sure in this is right polarity. If you install it into wrong polarities, may be broken or burned from the capacitor in the electrolyte. And the next one here. This is in this is a yellow capacitor that is called the ceramic capacitors, and for the green that is we call Mylar capacitors. And in this I think this is a tantalum capacitor. For in the group that is tantalum, Mylar, and ceramics capacitor. They are not having a polarities. I don't tell you about the voltage that is a support for the capacitors. Please check the voltage maximum for each capacitor types. Here in electrolyte capacitor, it is sets the maximum voltage at 35 volts. You can give the maximum 35 volt. I don't recommend this. You should maximum only 80% from the 35 volt. And the next one here, this is we call the variable capacitors. That's it. The variable in this type you can adjustment the capacity from the capacitors. From the capacitor have the value to check the capacitance. That is called the index. This is 4700 microfarad. Here this is the capacity from this capacitor. For this is 103K, 10TK. That is a 1000 picofarads. 3 is mean like as you have 3 zeros. You will have the number is 10,000 picofarads. So here this is 15 picofarads, 7 picofarads, 10 picofarads, and here in this is just 200 maybe 0.22 microfarads here. Okay, here this is a capacitor. For the next one in this is we call resistors. The resistor have a resistance. The resistance is a unit that is in form ohm, omega. And here in this resistance, and this is a resistance have the parameter, the value is 120 ohm, 5% errors. From this is a no label about the resistance, but the chip maker they scan the color to show the code from the resistance. You can check the code of the resistance from the internet. I will search and show you. Here, this is a code for the display the resistance from the resistors. Here, in this is have a 3 band. 1, 2, 3. What is the band here? This is 1, 2, 3. 3 band first. The 3 band first that is display about the resistance, and the last band that is display about the error rate or tolerance rate. So here this is 0 blacks, 1 brown, 2 red, 3 orange, 4 yellows, 5 green, 6 blue, 7 violet, 8 gray, 9 white, and here gold and silver that is related to the error. By the gold is related to 5% and silver is related to 10%. The size of the resistor that is related to the power that is the resistor is tolerance. So here this is in this resistor I think about over 1 watt. So here this is a very small resistor, maybe only 0.2 watt, and here this is maybe 0.5 watt, and here maybe 1 watt. The next one, that is inductors. I don't forget to tell you the resistor in Thai called R. And the next one, inductors. The inductor in Thai called L, or sometimes called in Thai words is a coil. The inductor that is made from the copper wire and circle and circulate around I think it is maybe iron. Some inductor is made from the fluoride. Fluoride is iron mixing with carbon. That is we call fluoride. For the core made from the iron and fluoride have a difference. By when you make it from the iron, it is supposed very low frequency. Look at here, this is a transformer. The transformer body is made from the iron. That is support over only the frequency not over 100 Hz. For here, this is the core is made from the fluoride. That is iron mixing with the carbons that supports the high frequencies. You will find the inductors in the circuit for inside the switching circuit. That means inside your power supply from your notebook, inside the power supply in the regulated mobile phone. Here inside is made from is used iron in the inductors. The next one that is like as the iron, that's called transformers. So here this is a transformer. In Thai we call transformer in the name of Morban transformers. The transformer have usually the transformer have two parts. The two parts of coil. The first part coil for send for when we give the power or voltage to the transformer we call the primary coil, and the next then the second part that we call the secondary coil. The transformer have two type of the body that is in the picture. It is an iron that supports only low frequency. Is similar to the coil that I told you, and sometimes in the transformer is made from the polarized coil, polarized body that is running is very high frequency, about start from 10 kilohertz until I found maximum about 100 kilohertz. This is used in the circuit to convert the high voltage to low voltage, or voltage from high voltage from low voltage to high voltage in the switching circuit. Here, this is about 4 group in the passive device. Now, the next slide we talk about the active device. The active device is made from the silicon chip. Inside have a P-type and then N-type. Can you remember P-type and N-type? When you have a pure silicon and mixing with borons and or mixing with antimony, that is will be the P-type and N-type. So the active device here in this picture is a diode, and the next one here and T-pin is transistors. In the group of the transistor have a bipolar transistor, MOSFET, IGBT, resistors. This is a group of the transistor. For more detail, you can search or read from the or sitting in the class about the electronics device. And the next one, that is the LED light emitting diodes in this picture. The LEDs is produce the brightness. We use LED for indicator, and when we build a large display, we can make it from the tons of the LED to make the large display board. So the LED, and when you move in back to 20 years ago, the LED have only 3 colors. That is red, green, and orange. Red, green, and orange. For the main three colors to produce and mixing any change in the color, it should be RGB. This is the red, green, blue. So in 20 years ago, we don't have about blue color LED. Now after, I think professors from Japan, is maybe they invent the blue LED, and after that he had the Nobel Prize from the invention about the blue LED. So after we have a blue LED, we can mix the color red, green, blue to produce any change in the color. And the next one, this is an IC, example IC 555. All components from the passive and active installed into the PCB pin circuit board, right as these features. For the next topic, I told you processors. What is a processor related to computers? The computers have the many types in the computer system. Inside the computer have 4 parts. That is the first part. This is the processors. We know processor is the CPU, and the second part is the memory. Here, memory. And the third, that is I/O module For the I/O module, as I told you, this is related to all device input output connected to computer. All of the device connects and transfer by use cable that is called system bus. Inside system bus have data bus, address bus. I will tell you later for the next chapter. For item here, that is include into the that is a building into the computer. The computer not only PC computer, desktop computer, laptop, or tablet. That is related to about any device. Example, inside a mouse. Inside a mouse, some mouse and some keyboards. Most of the keyboards have microcontrollers. I think you will confuse about the words microcontroller and microprocessor. Okay, now I show you in the next slide here. For the microprocessor, we can grouping into 4 types inside. The first, that is the microprocessors. The word microprocessor is come before GPU, DSP chip, and microcontrollers. The microprocessor is occur about before 1980, about the Intel and Motorola maybe create a microprocessor chip. Intel invent the x86 for microprocessors. For the microprocessor, that's doing the related design for instruction, that's do the general work. What is the general work? General work is related to about the calculation, the addition, subtraction, multiplication, calculation in the advanced mathematics, sine, cos, tan, and also copy data, transfer data, bit check, encodings. That is related to the general works. The microprocessor is the CPU in all computers, in all tablet that do in general works. You can bring the microprocessors to create parallel processors by install the microprocessor chip or CPU chip into a motherboard. Some motherboards install that 2 or 4 microprocessor that do the parallel processor. High performance desktop computer maybe have 2 microprocessor or sometimes called 2 CPU. That's called workstation. For the users, they know the CPU, but when you learn in this class, the CPU and microprocessor, this is the same meaning, but it's different meaning in size. Okay, difference in the detail in size. Okay, the second one, that is the I don't tell you the microprocessor. For the first version from about 10 years ago, the microprocessor have no input-output port, but today is different because after Intel and AMD, Apple, they invent the microprocessor chip that have include the GPU I/O into the chip. For including GPU I/O into the chip, we call they call the new name, that is the SoC, system on chip. The system on chip, that is indicate all system into the chip. Why the chip maker they integrate I/O GPU into the chip? Because it reduces the transfer speed from the GPU to memory and to the I/O device. All of the module installed into the wafer into the chip, so the transfer very fast, very high speed. When connect to individual device by passing data to the motherboards, may be loss of the communication occur, and also have a problem about noise when you have a very long line, you have a suffer about the noise from the another device that is attached to the cables. Okay, the main point in this, you will know about the microprocessors, and I think you know about the name. This is a SOC chip. For the second here, this is a GPU abbreviation from the graphics processor unit. The graphics processor unit, this is a CPU, this is a processor, but the main point in difference, that is a GPU have the specific instruction set. What is specific instruction set? I suppose you have a pictures about full HD pictures. The full HD picture have the resolution about 2 megapixels. 2 megapixels, that means in the picture, in the raw data, that the picture have 2 megabytes per picture. So when you drawing an object into the screen, that means you drawing a pixel X and Y on the screen. And when you move from this part to this part in the screen, that is moving from X, Y in this location to a new location. So moving in the location is doing transferring the data in memory in the GPU. The GPU relate to coordinate, calculate X, Y on the memory. That is related to mathematics about coordinate calculation. That is related to vector calculation. So specific instruction set, that means the instruction set special for calculation X, Y position in memory, for transferring, addition, moving data, not for the copy data, bit check, encryption. That is a work for the microprocessor. And the special one, that is the dual pulse memory interface. For the microprocessor, for the GPU graphic processor, is send or transferring a tons of the data from the memory to the GPU. So in the VGA card or GPU or the graphic cards, the chip maker design a special memory. By the memory have a difference from the memory in the microprocessor. Look in these pictures here. Can you see the memory here? In this memory have only one load. I represent a load. This is a system bus. I have only one load or maybe two lanes inside for read or write the data from the CPU to the memory. But in the memory for the GPU have a special lane here. Represent special lane here. That means have like as a 4 lanes the loads. You can send or receive the data more a tons of data to memory in and out. So this is special for the graphics processor unit. The graphic processor, the chip name current today, that is a GeForce from NVIDIA GeForce, GeForce and Fordo from NVIDIA, and from the AMD this is Radeon's 5 Pro is maybe. This is the name, the product from the chip maker, GPU maker. The third in the group of the microprocessor, we call the DSP chip. That's the separation from this digital signal processors. Digital signal processors. That means this device is processing the signal. The signal, we know the signal have two types: analog signal and digital signal. Not only the analog convert to digital, that is not only this method, but when you have a digital data, maybe you relate to the decoding or encoding the data. Think about when you transferring the data from the mobile phone to the Bluetooth headset to the Bluetooth headset. This is a transfer in the digital communication. Digital communication inside the digital signal. That is encoding from the transmitter. When after that the receiver is decoding the data and change from the digital signal to analog signal. So here the main point for encoding and decoding is a work from the digital signal processors. You will find the digital signal processor in a lot of devices. Example, Bluetooth headsets and piano and electronic music generators. Example, piano, drum, special about the synthesis, the music that is related to the digital signal processor chip. The digital signal that I search from the internet, the chip that is famous from Texas Instruments is a C6000, and for the analog device, this is a charge, and for the creative creator soundboard is a EMU10K. Yeah, this is about related the microchip name that is related to the DSP chip. The last one here, this is a microcontroller. The microcontroller is a type of processors, but have a specific instructions for support the works about the transfer, input, output, controlling in the very low speed device. What is a low speed device? Example, washing machine. A washing machine, microwave. The washing machine have a panel. When you set the function for washing, that is a time washing and spendings, or time start or stop or time. Some special in washing machines have a function about the intelligent. Example, as is a fuzzy logic, that is a automatic calculate the number of the weight and waters in the tanks. So for the microwave, some toys that is have a microcontrollers. The microcontroller indicated the I/O, timers, memory. Some type of the microcontroller installed include the Wi-Fi, and most of the microcontroller have ADC and DAC inside. ADC is analog convert to the digital signal, and DAC is the digital signal convert to analog signal. The chip that is in the group of the microprocessor is a PIC from the microchip company. MSC51, that is a X051 from Intel. ARM as the companies maybe about the microchip. Maybe I can tell you about the company from ARMS. Okay, here for the conclusion here, the microprocessor have in the group of the microprocessor have 4 types. For the processor have a 4 types. That is a microprocessor, GPU, DSP chip, and microcontrollers. Okay, here this is example of the Arduino boards in the group of the microcontroller. In the Arduino boards have analog pin to get the analog voltage from the externals, have a serial in, serial out, send the serial data, and it have a digital I/O to control the electronics device, and have external powers USB plug. Okay, here this is activity is doing in the class. That is finding the chip from the internet. You search CAD and the name in the list that and tell me in each name what is the microprocessor, microcontroller, DSP, or microprocessors. Here this is a type 88-bit, 16-bit, the company makers. Okay, now I think we have a lot more detail in for this chapter. Okay, thank you. Bye bye. สวัสดีครับ